Welcome everyone to the lightning talk session and the poster preview session. We will have 3 lightning talks, and then we will have 11 poster preview talks. The lightning talks are independent. The poster preview talks go with the posters that are in the poster room in the Gather virtual world in virtual chair. So immediately following this session, go back to Gather. If you're in the lobby, go down, and below the lobby is the poster room, and you can go there, and speakers, please go there as well and stand next to your poster. You can ask the speakers questions. So you can see here the preview, get an idea of the poster, and then after this, we'll have an hour session where you can talk to the presenters themselves, and then we'll have half an hour of just kind of social gathering inside a virtual chair. Let's get started. The first speaker is a lightning talk, and it's Sunny Sion Khan. So please go ahead.
Thank you, David. Recent regulatory investigations of big tech's anti-competitive behavior have resulted in a DOJ lawsuit against Google and potential action against Facebook by the FTC. What these antitrust actions seek are legal remedies that introduce structural reform, but current competition laws haven't been designed to address information monopolies, namely the exclusionary access to data that enables companies like Facebook, Amazon, and Google to edge out competitors. Big tech's power derives from the consolidation and gatekeeping of data, and this was the motivation for Facebook absorbing burgeoning competitors like Instagram and WhatsApp. When regulators failed to block these acquisitions for over a decade, the tech market divided into the haves and the have-nots, the incumbents with an exclusive, far-reaching vantage point built on data, and the outsiders that lacked the information capital to even enter the arena. It would be a very lengthy and a messy process to break them up, but meanwhile, a proposal for a fair and equal data sharing mandate can level the competition, especially when adopted with privacy-enhancing technologies like secure multi-party computation to protect the underlying consumer data. A data sharing mandate is a technological solution outside the box of doctrinal law that would require technology companies above a certain market cap to share a representative subset of their data with their competitors. Because to combat monopolistic power derived from data, big tech should share what they know and make this information widely usable for current and potential competitors. Additionally, this approach can widen economic activity on data without unduly constraining incumbents and impacting consumers. So this is a short talk, but to learn more, please check out my article on just security shown here. Thank you.
Thank you. And next is Alexandra Korolova.
Hi. In the world of information overload, targeted advertising is a crucial way to reach people on important issues, such as job opportunities and political arguments. You may think you know how such advertising works. An advertiser specifies a target audience of people it wants to reach, their message, and their budget, and then users in the targeted audience see the ad. So if there are any abuses, such as only men seeing ads for programmer jobs, they must be coming from the advertiser's discriminatory targeting. But that's not the case. There's another player that significantly affects the outcome of who sees which ad, the ad platform itself. It does so through its ad delivery algorithm that decides which of the many ads targeting a particular user will be shown to that user. The ad delivery algorithm used by platforms such as Facebook is opaque and optimizes for a combination of objectives, such as the platform's business interest, advertiser satisfaction, and user engagement. In our research, we have shown that these delivery algorithms and not advertiser choices can lead to societally undesirable outcomes. Specifically, they can lead to job ads being delivered in a manner that is skewed by race or gender, even when the advertiser targets a large and racially balanced audience. They can also hinder political campaigns' ability to reach voters who don't already agree with the campaign through differential pricing and echo chamber-like delivery imposed by the algorithm. Which brings me to the reason I'm participating at this workshop. For this important domain of deciding exposure, we need a combination of computational and legal advances to enable meaningful societal oversight and bring changes that can align societal desiderata with platforms and advertiser goals. Thank you.
Next is Eileen Nielsen. Go ahead.
Hello, and thank you, David. My name is Aileen Nielsen, and I'm a fellow in law and tech at ETH Zurich, where I try to work on problems to unify law and technology approaches. And the topic that interests me in this work is the problem of the unduly accurate algorithm, which I think is something that is bothering many of us in various forms, as we see from the selection of lightning talks and also of talks at this conference. So my first point is that accuracy itself can be problematic in the algorithmic society. To this point, the law and tech literature has often focused on problems that occur when algorithms misbehave or fail to achieve whatever their targeted task is. But I argue that many problems that bother people, such as the potential for extensive surveillance, the problem of algorithmic bias, the potential economic disruptions, and other legitimacy problems from human replacement might actually come from algorithms that behave too well. Other examples of algorithms we don't want behaving too well: targeted advertising, so-called gaydar, social media. And so I propose a solution which I call accuracy bounding, which would basically just be context-sensitive limits on accuracy, either for a trial rollout or for permanent protections. This has a basis in all sorts of regulatory history, such as the rollout of GPS by the US government, and also by private industries such as OpenAI and the rollout of their NLP models. I argue that there would be a lot of benefits to considering accuracy bounding as one of many regulatory tools. It would help refocus industry on metrics other than accuracy, such as fairness, robustness, and transparency. It would control knowledge and power that perhaps should not be algorithmically available or not easily available. And it would bring a greater conceptual convergence of legal regulations and technical parameters. I have a draft I'd be happy to share and look forward to any feedback during the social session. Thank you.
So now let's move on to the poster preview talks. The first poster preview is Shruti Agarwal.
Yeah, hi everyone. So I'm Shruti Agarwal, a PhD student from UC Berkeley, and my research focuses on the problems of multimedia forensics. So today I'm presenting a poster on fighting deepfake misinformation. So in recent years, we have seen that deep learning has enabled the creation of high quality and highly realistic fake content, fake audios and videos, where we see individuals saying or doing things they never said or did. So as famous people with the large internet presence are the most vulnerable to such type of fake content. In our work, we focus on detecting deepfakes of political leaders, politicians and world leaders. So in order to do that, we exploit the fact that when a person talks, they exhibit certain regularities of facial movement and expressions. And we model these facial movement and head motion when a person is talking and show that such regularity in the facial movement are disrupted in the creation of deep fakes. So in order to know how we model the facial movements and how we exploit it to detect the deep fakes of an individual, please visit my poster during the social session. Thank you.
The next speaker is Bhushan Suwal.
So the US Census Bureau is using a differentially private algorithm to noise its counts for its data products, most notable of which is the 2020 census count release, which is going to happen next year. We investigate how having different epsilon budgets and different ways to split the epsilon among the queries affect how much error you can expect in your district. We also see how the noise affects the robustness of certain regression tools used by plaintiffs to launch VRA cases. We do all of this by building a simpler toy model where we just noise the total population, and then we add increasing amounts of complexity like non-negativity, increasing the workload by adding multiple subpopulation buckets like race and age. And in the end, we run the census's full algorithm on reconstructed 2010 census data. And all along the way, we observe the error variance and expected error magnitude. So one lightning talk punchline is that to minimize the error, we want to be building compact districts out of bigger geographical units. I am happy to field more questions and talk more about this work in the poster session. Thank you.
Okay, thank you. So as we know, in the current data ecosystem, platforms collect huge amounts of data about each one of us. The data is then analyzed on a community level, and it enables platforms to train algorithms that divide their users into subcategories and then present each category of these categories with personalized content. While personalization has benefits, it can also have adverse consequences for individuals and for society. Personalization of content can even go as far as creating completely different perceptions of reality for different groups of users. So while one user may be shown information about a potential cure for cancer, the other might be presented with information, for example, on where to buy or how to operate the newest automatic weapon. This is really dangerous, not only because it could perpetuate fake news and conspiracy theories, but because it influences public discourse and it creates polarization that impacts the foundation of our democratic processes. It also raises many questions. For example, when should categorization be permitted? When do personalized offers constitute discrimination? And finally, who is it that's making decisions in these matters? The insurance market has been dealing with similar questions for decades. Big data enables insurance companies to categorize their customers and to offer each group different treatment, whether by refusing to provide insurance to certain categories of people or by charging higher premiums for the same service from others. I suggest that understanding how questions of categorization and discrimination have been addressed in the insurance market can help guide the discourse around these issues in our context. The data ecosystem has a profound impact on our lives. Sitting back and not taking action means that we're allowing platforms to make the decisions that shape this space. And there's simply too much at stake. I believe that building on this comparison, we should be the ones to collectively decide on the rules that we want to govern the data ecosystem. Thank you.
This is the presentation on digital forensics use in criminal court case descriptions by Ryan Aponte and Dr. Christy Nelson. This work was done for the Federal Law Enforcement Training Center, FLETC, and the Department of Homeland Security. We want to answer, how can text-based machine learning and keyword analysis of Thomson Reuters Westlaw federal criminal court case opinions provide insight on the changing landscape of digital forensics and its use in trials? If FLETC has a better understanding of digital forensics use at trial, law enforcement training can become more tailored. We also look for trends in digital forensics use. Westlaw is used to obtain court case opinions from January 1, 2015 through June 30th, 2020. Month and year were extracted from the documents to assess trends in digital forensics prevalence. To determine whether a document is related to digital forensics, we see if it contains at least one associated keyword. At first, we searched their database using brainstorm keywords. They were not very technical and included a hard drive and iPhone. The most frequent word is the minimum number of cases that involve digital forensics. Digital forensics textbook dependencies are also used to obtain related words. They range from less technical words like firewall to the digital forensics specific software, the sleuth kit. There are nearly 300 keywords, causing a limitation that many may not be exclusively associated with digital forensics. One word, app, means both program and is part of an abbreviation for appendix, which is used in legal citation. Future work will need to remove these words. We found that in the first half of 2019, cell phone became a more common term than computer, as well as that the latter term is declining in frequency. Looking at how common these two terms are, they appear in a small fraction of documents. Some highly technical terms, such as the sleuth kit, do not appear in any of the 250,000 opinions. Future work can extend data collection to state courts and recommend how to apply our insight to FLETC. Thank you for listening to our presentation.
So I'm Scott Griffey, and I'm presenting abradable key wrapping, which is a paper I worked on with Charles Wright and Mayank Varia while getting my master's at Portland State University. So abrasion is an answer to the problem of providing governments with limited access to encrypted data without enabling unauthorized access by non-government actors such as hackers. Abradable cryptography enables many independent parties, such as messaging platforms, to encrypt data so that there is a large one-time cost that the government must pay in order to decrypt any data. This one-time cost ensures that it is impractical for low-resource attackers to decrypt records. The existing abrasion construction uses Diffie-Hellman to create this type of puzzle, but this suffers from possible backdoors and lacks a thorough security analysis. So In this work, we provide a new construction of abradable cryptography based on hash functions and time memory trade-offs. Our construction is the first to meet a rigorous security guarantee. So concretely, we can show that our construction enables an authority that can spend $1 billion to obtain access to many records, while at the same time, we can prevent an adversary who only spends $1 million from decrypting even a single record. These costs can be tweaked, and this 10-to-1 cost ratio remains stable over a variety of configurations. And all these talks look great. So just to differentiate mine, it's a bit more technical. I think I go into the details of time memory trade-offs a little bit. So if you're interested in that, that's just a preview. Thank you.
Hi, everyone. I'm Carney from Ottawa University. I'm a postdoc there dealing with AI and regulation. And in the last spring, Professor Niva Elkin-Koren from Tel Aviv University, Professor Victor Gal from the Technion, and Shlomi Hod from Boston University, and myself taught a course for both law students and data science students aimed to foster dialogue between the two disciplines. Now, it was taught over a period of 2 months. It consisted of 6 4-hour interactive workshops, originally intended to be like an in-person course, but had to switch to the virtual arena because of COVID. And we wanted to share a little bit with you on the course, how it worked. Our objectives teaching the course was a realization that collaboration between both disciplines is becoming more and more important, especially at early stages. And we wanted to also leverage the dialogue between students from both disciplines to create a better, more deeper learning of the term responsible AI. So how did we do it? In each of the 6 classes, we had mixed teams of 2 law students and 2 computer science students tackle a data-driven legal study, legal case study. In order for them to make progress with their task, they were forced to collaborate, which was challenging at first, but improved during the course. For example, the first session, the first class, the mixed team received data from the camera of an autonomous car, which was involved in an accident. While analyzing the computer vision model, they were able to come up with legal arguments regarding the fault of the different parties based on the technological evidence, which they could not have done if they had worked separately. We would love to talk to you later in the poster session about our learning objectives and about the pedagogical principles that guided us, as well as more details if you want on the structure of the course and what worked well and what was more challenging. We would also like to share that with you that the course there will be an extended second edition of the course within 3 institutes collaboration: Cornell Tech with Professor Helen Nissenbaum, Tel Aviv University, and the Technion. And we also plan to release the course materials under a Creative Commons license for the community to be able to use. So if you're interested in that, we would love to speak later. Thank you very much.
I guess best so I find an essential purpose of work at the intersection of computer science and law to be the refinement of our scientific modeling. As computer scientists, we see problems arising in society and nature, and we have to reduce them to mathematical terms that a computational solution is well defined. So part of this intersection is about doing so in a way that is amenable to legal analysis and consistent with legal theory and practice, so we can build justifiable and governable systems. And we've seen various examples of this in the past 2 days with singling out, compelled decryption, and data co-ops. But there's a certain pattern often present in the scientific process of modeling and algorithm design, which creates potential hazards to legal and sociotechnical analysis. Specifically, oftentimes our problem models and our algorithmic solutions have caveats, qualifiers, and limitations, which are not inherent to the problem itself, but are instead introduced by computer scientists through our own techniques and theory. These objects, and I focused on 3 types: heuristic models, assumptions, and parameters, may be opaque and obscure to non-technical researchers and law and policy makers, while still holding immense and even total control over the expressed behavior of the computation we are trying to legally reason about. So heuristic models and computations arise in cryptography, verification, cyber-physical systems, and they limit the confidence we can have in the correctness of our algorithmic solutions and their expression as software and hardware. Examples, if you're familiar, include the Dolev-Yao model, the random oracle model, cryptographic hardness assumptions, and our mathematical interpretation of physical objects like sensors and servos. Parameters arise pretty much everywhere, including cryptography and differential privacy and very robust machine learning. They allow us the freedom to set and tune the effects of a computation through implicit fixed sigma and algorithmic family. But for many problems, that selection bears considerable socio-technical complexity, such as the canonical example of a privacy budget and differential privacy trading off privacy and utility. I see there's being 6 main hazards that arise from these objects. They are opaque and obscure. They give a pretense of formalism and truth, may have mathematical complexity that aggravates their socio-technical complexity. They may be indeterminate and unfalsifiable, may not have a constituency in the research community, and may be a soft underbelly to subvert law, policy, and regulation of computation. So my work is about these hazards and some ideas I propose to help educate and elucidate the nature of these objects for work at the intersection of CS and law and CS and society more generally.
I'll be presenting a poster on ensuring fairness in the absence of protected group membership attributes. As most of you know, recent studies have pointed out different kinds of gender and racial biases in automated systems. And therefore, auditing and mitigating biases in these systems is really crucial towards the development of inclusive AI systems. However, most prior approaches to address these social biases require access to protected attribute values, such as gender or the race data of the individuals represented in the data sets. But in many applications, these labels might not exist, or their presence might impose problematic partitions on the protected group. We propose the use of diversity control sets instead of labels to audit and mitigate these biases. In our frameworks, diversity control sets are a small set of diverse examples from the domain of interest. And the objective is to ensure diversity in a similar manner as the control set. In our recent paper in CSCW and ongoing work, we show that control sets can be used to obtain fairness in image and text summarization applications, as well as to audit gender and skin tone diversity of any given image dataset in the absence of protected attribute labels. There are different societal and policy nuances associated with the use of control sets, and I would be happy to discuss them further in the poster session. Thank you.
My name is Devashree, and I'm a graduate student in computer science at Harvard. I'll talk about a challenge in the area of digital preservation. If I can get this to share. Right. And this is joint work with John Bowers, Jack Cushman, and Jonathan Citrin. So archivists face a wide range of challenges in maintaining archives, such as data breaches, inadvertent loss, and legal coercion. And these threats are particularly salient in the case of sensitive materials that are donated with delayed release conditions, such as those only to be unsealed after the passing of certain individuals. And ensuring that donors can trust in this ability to enforce such conditions is critical to the long-term preservation of our historical record. Archivists have spent decades developing best practices around technical and administrative risk, but these safeguards are not holding up enough in the face of rapid technical progress, growing volume of digital artifacts, and increasingly aggressive efforts by parties to secure early release of materials. So we propose a protocol called Strong Dark Archives, which is an integration of technical and legal methods for secure delayed release archival. And it's designed as a supplement to the existing best practices for long-term stewardship of digital materials. And the protocol relies on a trusted network of certified organizations that are willing to work together, and through threshold cryptography, legal contracts, and institutional mechanisms, the protocol ensures that a given threshold of parties must come to a consensus in order to release the sensitive materials. So on the right-hand side here, we see that with the traditional model of archival, there's a high chance that sensitive materials will be disclosed prematurely due to legal actions. But with the STA model, any legal action must succeed against at least 4 of the partner libraries. So notice that STA does not foreclose the possibility of premature release in the case of exceptional circumstances, but it provides increased clarity and gravity to the decisions and processes around such early disclosures. And the key takeaway for us is that technical, legal, and institutional mechanisms need to be co-developed and co-designed in order to account for the different mechanisms of release and to ensure donor trust in the preservation of digital materials. And if you're interested in learning more, please check out our poster in the poster session. Thank you.
All right, thank you. So I'm a PhD student in computer science at Boston University. And today I'm presenting a poster called Formalizing the Right to be Forgotten. So Aloni introduced this work already in his talk, but if you missed it, basically the right to be forgotten gives users the right to erase themselves from a data controller. And so our question is, what does it precisely mean to erase? So based on existing legal literature, we came up with two sort of notions of erasure, one called confidentiality and one called control. So confidentiality is based on the idea of preserving privacy, and this has been sort of well studied in the computer science literature. But control is about the idea of users having autonomy over their data, and so when we erase someone from a data set, they should be sort of completely removed, and the data set should bear no trace of their presence in that data set. So in this work, we present the first formal model of this control notion of erasure, guided by various sort of touchstone data controllers. And we found in general that this concept of erasure as control is just very unintuitive and sort of difficult to reason about. And so, yeah, so it's just sort of a new idea. And this is an ongoing project, so I'd be happy to hear any feedback from either law or computer science scholars about it.
Yeah, so I'll be talking about mitigating bias in subset selection. This is joint work with Professor Elisa Celis at Yale University. Subset selection is a fundamental problem in machine learning, which arises in various ML systems used in the real world. For example, those that might be used by employers to select a subset of people to hire for a job, or by a bank to select a subset of people to give loans to. As such, it is extremely important to ensure that subset selection algorithms do not discriminate on basis of protected attributes such as the race or the gender of the people being selected. One way to ensure this is to place constraints on the final subset, which is selected by these algorithms. So for example, one constraint could say that the final subset should not have more than 80% of the individuals from any one particular race group. And these constraints can vary depending on the context and the requirements in that particular context. However, the current subset selection algorithms assume that they have access to the protected attributes for all the individuals involved in the subset selection process. In the real world, there might be noise added to these protected attributes to guarantee some kind of privacy to the applicants. And these protected attributes might not be available for all individuals. For example, if these are collected on a voluntary basis from them. Under such real-world situations, existing fair algorithms do not achieve their guaranteed fairness and non-discriminatory requirements. This brings us to the main question we ask in this work, which is, can we develop an algorithm for fair subset selection which works even when the protected attributes are noisy? In a recent paper on Archive, we show that this is indeed possible, and I invite you to come to the poster to learn more about it. Thank you.